Hey, here's Mr. Maestas, and it's like I'm introducing myself. Here's Mr. Maestas. Um, here I am today, and I am going to talk to you about measures of central tendency and variation. So this is an Algebra 2 video, even though I teach AP Statistics, and we get into a little bit more depth about what all these are. And I really think that the most important thing is you understand what measures of variation are and what they mean in context of a situation. So I will talk about that towards the end, even though we're just looking at how we calculate it. I will also talk about why it's important that we do that. So let's take a look. Here first is the definition of what a measure of central tendency is. Basically, we're looking at what's happening in the center of our data. We're talking about a set of data, and we want to know a number that it represents that center or the middle of that data. And those data represent, the middle of those data are represented by either the mean, median, or the mode. A lot of times we don't use the mode very often. Our mode just tells us kind of what's most common, but we will use the mean and the median to describe the center or the central tendency of any set of data. So let's take a look. Here are the definitions of the mean, median, and mode. The mean is the average, and I assume by now that you know how to do the average because you've seen it before. The median is not the average, so don't look at this. The median is not the average. Okay, I don't like that number there. I don't know why it was put in these notes. The mean is the average. It's what we do to find the mean is we add all the data values, and then we divide by the number of values that there are. So you've probably seen that before. The median is the middle number. So it's the middle value of your data. So what you do is you put the data in order, and then you just divide by 2 and find out what the middle number is. Okay? And the mode is the most frequent one. So let's say we have an example here. A website company has 3 employees who are paid $300,000, 10 who are paid $100,000, and 60 who are paid $500,000. Let's go and find the mean, median, and mode. So to find the mean, all right, we have 3 employees. If I line this up, I would have 300,000, 300,000, 300,000, and then I'd have 100,000, 100,000, 100,000, all 10 times, and then I have 60 people are paid 50,000. So I have 300,000 value frequency. I'm just going to make a little frequency table here. All right, there's 3 people there, 100,000. There are 10 people there, and 50,000, and there are 60 people here. Who makes most money? Or not most? Who makes the most money? Obviously, these 3 people here make the most money, but what do the majority of the people make? 50,000, right? So this right here, this is the mode. This is what most people make in this company. What's the mean? Well, the mean is going to be the average of this. So let's say I have 3 of those guys. So 3 times 300,000 plus 10 times 100,000, because I have 10 of those guys, plus 60 of my 50,000s, divided by the total number of things that I have. It looks like I have 73. So I'm dividing that by 73 people, right? Or 73 employees. And that's going to give me my average. So let's go and see what that average is. And I'll go and put that in my calculator. So I'll pull up my calculator here. All right, so I have 3 times 300,000. Whoa, that's too many. 300, 1, 2, 3. Gosh, why is it doing that? Plus 10 times 100,000. That's 3 million. I got too many zeros here, guys. Okay, 100,000, that's right. Plus 60 times 50,000 divided by the sum of those is 73. And I want to Control enter that. $67,123.30. All right, so 67,123 30 cents. All right, so there's my mean. Okay, this is my mean. How about my median? Well, my median I'm going to find by the center number. So here's how I'm going to have to do the median. I have 73 total people there, right? So I have 73. Since it's an odd number, I'm going to add 1 to that. If it was an even, I'd straight up divide by 2. Okay, divide by 2, and that gives me 37. So I'm going to go to the 37th data point. Okay, the 37th data, and so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, all the way to 37. And notice I'm still going to be in these people, right? If I started from 50, I have to start from 50,000 because I got to go least to greatest and keep going up to 300,000. There's 60 of these people, 10 of these people, and 3 of these people. So if I started here at the first person, I would end up at the 37th person still right here. So my median in this case is 50,000. Now let's just talk about this real quick. Notice that the mean is bigger than the median. And the reason for that is because we've got these people that are earning 300,000. So our average is going to be higher because we've got some higher people than our median. Which one looks more attractive? Well, obviously the higher one. But it kind of skews our data. I mean, it's a little bit skewed, right? Because we're thinking, wait a minute, our average might be high, but or 67,000, but that's because we've got these people here, really not a lot of them, that make a lot of money, which is pulling our average higher. When in reality, most people make around $50,000. Okay, so that's the mean, median, and mode. If I was looking at that same case, what would I want to use if I was recruiting people? Well, of course, I'd want to use the mean or the mean salary because it looks better. Is that what you're going to be earning? Probably not, right? Probably not. You're probably going to be earning around the 50,000, unless you're a top employee. Then you'll be over here. Okay. So what else can we use? Well, we can use a measure of what we call variation, and a measure of variation is how far the data are spread out. So this means basically, if I know that my data are spread out a lot, so if I know, we'll use that idea here that we just started with. Okay, I've got these 3 salaries. Okay, the difference between these 3 salaries is kind of a lot. And if I had a measure of how far these were, if I had a company that was just this, okay, and I had a measure of how far these were, and I knew what that measure was, I could say, well, wait a minute, these are much closer together. I'm more likely to get paid around the same than in this case where they're really far apart. I'm more like, I don't know what I'm going to get paid because there's so many different variation in here. All right, so how do we figure out those numbers? Well, we've got 2 numbers. We got variance and standard deviation that tell us how far apart these data are. So here's how you find the variance. First, you got to find the average. Once you find the average, you subtract each of the values from the average. You take that difference and then you square it, and then you find the sum of those. So you're just going to add them all together, and then divide by the number of terms. So you're basically finding the average of all these differences, and that's the variance. And then, of course, to find the standard deviation, you're going to take the square root of the variance. Okay, so let's work through one, and then you can try one, and then that's pretty much it. Okay, so find the variance and the standard deviation. So the variance, what we're going to do is we have to first find the mean. So let's go ahead and find the mean, and I'm just going to do this very quickly in the calculator. All right, so I'm gonna find the mean. All right, so I found that the mean is 41. I did that by adding these up and dividing by 10. So then what I'm going to do to find the variance, okay, so to find the variance, what I'm going to do is I'm going to take each of these and subtract it by the mean. So I'm going to do 48 minus 41. Okay, and then I'm going to do 36 minus 41. And then 40 minus 41. And so forth. And then when I find whatever that is, I'm going to square that. Okay, I'm going to find out whether to square that. And I'm going to find out whether to square that. Okay, so then I'm going to figure these out. So that's going to be 7 squared, which is 49. And then that's going to be 5 squared, which is 25. And then this right here is going to be 1 squared, which is 1. And then I'm going to keep doing that, dot, 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 until I get to the end. 37 minus 41 squared, which is 4 squared, which is 16. And I'm going to take all of these, I'm going to add them up together. Okay, add them all up, and then I'm going to divide by the number of terms, 10. And that is the variance. Okay, so let me quickly throw that in there so you can see what that looks like. All right, so I put all of these in here, and I squared them all, I add them together, and then divide by 10, which is the number of terms that I have. And then I get the variance, which is 40.5. To find the standard deviation, I take the square root of the variance, which is the square root of 40.5, which is, let me go over here, square root 6.36. So what this is telling me is that the average difference between this is kind of what it's saying. The average difference between these data points here, these data values, the average distance between them is about 6.36. That's what standard deviation tells us. How far apart is each of these data values roughly from each other? It's about 6.36. So here's a practice problem for you to try. It's really not that long. But what I'm going to talk about tomorrow in class, and just very quickly, is why do we use standard deviation? It's very important that you understand why we use standard deviation, that we're basically talking about the average difference between these values. I used a question in class, like, you know, if I knew that my, if I had a test, and the average test was, you know, on the score, the average test was 80%. Okay, this was my average, or my mean, right? On my test was 80%. You think, oh, that's pretty good. But if I knew my standard deviation was 20, then I was going to, wow, wait a minute. My standard deviation is 20. That means 20 on average. The difference between my scores were about 20 apart. That's crazy. That's like that's a huge difference between these points. But if my standard deviation was like 1.2, then I would say, like, on average, my scores were only about 1.2 away from each other. That means that they were really close to 80. Only about, you know, 70. I mean, most of my scores were only between like 78-ish and 82-ish. 78 to 82. That means that students were pretty consistent. Where here, this is crazy, man. That's very high. We weren't going to really see that, but even like 10, you know, even 10, that would tell me that my scores were somewhere between, you know, 60 and 100, which is, you know, that's a big standard deviation. That's a big difference between my scores, where this is not a very big difference between my scores. So standard deviation tells us how close things are together, where in this case we're pretty far apart. Okay, so that's standard deviation, guys, and I will see you soon. Talk to you later. Bye bye.